Hello and welcome to our 7th training video designed to provide insight into the purpose, properties, uses, and equipment surrounding R-1234yf. This video provides a more in-depth look into the refrigeration process by looking at the low pressure side of the system. To give a general flow of the refrigeration process, we can look at the figure to the left. I'll go through 4 main highlights of the process before going in-depth as we move through the video. Starting with the evaporator, the refrigerant absorbs heat from the inside air and changes from a liquid to a gas. From there, the gaseous refrigerant is compressed, which raises its temperature. Then the compressed refrigerant is condensed to a liquid, causing heat to be transferred from the refrigerant to the outside air. Finally, the refrigerant is expanded and its temperature and pressure are lowered before it starts the process over again. To start the process, you need to charge the system with refrigerant, but it is important to make sure that your system is properly charged. Low charge lowers evaporator and condenser pressures and can freeze the evaporator, while overcharged systems have high pressures and result in poor heat transfer in the evaporator. To ensure maximum heat transfer, which is the basic principle behind cooling hot air to cold air, it is important to have the correct refrigerant charge. Luckily, 1234yf and 134a have similar charge sizes due to their similar operating pressures and temperatures. To ensure that you are using the correct refrigerant for your car, you can always check the service label under the hood. Starting with the evaporator, we have a low-pressure liquid going in and a low-pressure gas going out. In the evaporator, the liquid refrigerant absorbs heat from the inside air and evaporates before heading to the compressor. To change state, the refrigerant must absorb energy, and because it is absorbing energy, it takes away heat, which makes the air flowing over the evaporator coils colder. This absorption of heat and change of state from a liquid to a gas is what causes cold air to be blown from your vents. Before reaching the compressor, the refrigerant passes through one side of the H-block or thermal expansion valve. Looking at the diagram on the left, we can see that we are looking at the top side of the valve in this case. Here, the refrigerant doesn't change state and enters and leaves as a low-pressure gas. The purpose of this pass is to trigger a sensing element in the expansion valve that controls the amount of refrigerant entering the evaporator. If you look at the diagram to the right, there is another pass through the expansion valve heading towards the evaporator. This is the expansion part of the valve, and this part of the process is crucial to making sure the system has the right amount of refrigerant flowing through it. Now we are at the compressor, where low-pressure gaseous refrigerant is compressed to a high-pressure gas. This raises the pressure and temperature of the refrigerant and causes a gradient that drives flow throughout the system. The refrigerant moves this way throughout the system because it is moving from a high to low pressure. It is also important to note that the compressor marks a switch from the low side to the high side of the system. That's all we have for you. Thank you for joining us for an introduction to the low pressure side of a 1234yf system. Check out our next video for more information about the high pressure side.